Okay, a firework is launched in the air, briefly comes to rest at the highest point in its path, and then it explodes into two pieces of masses 0.25 and zero point 0.5. A smaller piece is found to be moving with a speed of 50 immediately after the explosion. Calculate the speed of the larger piece.
So this is what we were talking about earlier, right? When it explodes in the air.
Right.
So both of those should add to the.
Well, so here's the thing.
Okay.
So immediately after the explosion, like the firecracker went up until it was like the final velocity was 0, so it just froze for a second, right? So
when it went up in the air.
yeah, so like right at the top it comes to rest.
Okay.
So right when it comes to rest, that's going to be our initial point. We're going to say MAVA initial plus equals MAVA.
So are these for the one piece and the other piece, or what is this we're writing?
Yeah, so the A and the B are the different pieces.
Okay.
And initial is just before the explosion, and F is just afterwards.
Okay.
So because it said it just came to rest, that's 0. Right. This thing's 0. Okay. So that means 0. It says the smaller piece has the speed of 50, so that's 0.25 times 50, right? Plus 0.5 times VB final. Right. And you can just like logic it out. Like if this thing has half the mass,
that has.
Or how about this? If this thing has double the mass of that, it's got to have how much speed?
Double the speed.
Half. Okay. To make this thing 0.
Okay, hold on. Where did this go though?
I'm just doing logic, right? Like if this has double the mass of this,
okay,
then for this thing plus this thing to equal 0, this had better have half the speed.
Half the speed. Oh, okay.
Yeah.
Yeah, I see what you're doing.
So they got it?
Yeah.
Okay. A ride has a radius. You can check the math. You'll get a negative 25, but they ask for the speed,
Yeah,
so it's 25.
I see what you're doing.
A ride has a radius of 10 and a mass of 2,000, which allow riders in seats, which are 7.5 meters from the center of rotation, while the ride accelerates with an angular acceleration of something. What is the tangential acceleration experienced by the riders? So remember the relationship between tangential and angular acceleration is equal to r alpha. Yeah, that's it. So we're looking at that one.
Okay.
And so they tell you what the angular acceleration of everybody is, and they tell you how far away everyone is. So
how do we know to use this? Is that just what it's asking?
Yeah, they're asking for the tangential acceleration. So, and they try to trick you by giving you two radiuses, like where the riders are and then how big the ride is. So like these are the riders, but then the ride is like a little bit bigger.
Okay.
But they want to know what's the tangential acceleration experienced by the riders. So we don't care about the. Yeah, we'll take the inside one.
Okay.
So that's 7.5 meters times the angular acceleration of 0.1 radians per second squared, and that's 0.75 meters per second squared. Yeah.
Of the.
Okay, and then.
Or of the riders, experienced by the riders.
Right.
And it's different than someone being on the outside.
Somebody on the edge would experience a bigger one.
Because they have a bigger
radius. Yeah. force is applied to a ball with a mass of 2 and a diameter of 0.5 in such a way that to cause it to angularly accelerate at a rate of 3 radians per second squared. How much torque is being applied to the ball?
Torque. So we're gonna have the inertia. That's what I is, right?
Yeah, well, okay, so they yeah, torque is equal to I alpha, right?
Mm-hmm.
And so force is applied to a ball with a mass of 2 kilograms and a diameter of 0.5 meters. So I have to go figure out what the moment of inertia of a ball is.
Oh,
I
that's
get
what they're gonna give us.
yeah. I'm gonna assume
That's 1/2.
that they're saying it's a solid ball.
Yeah. Not a hollow one.
Yeah.
It's gonna be different.
Yeah. And they would have had to give us the thickness of the thing. So
It was hollow.
yeah, so moment of inertia of, we're going to just say solid sphere, otherwise they didn't give us enough information. So according to Google, Wikipedia, solid sphere,
2/5.
2/5.
2/5 and 1/2 are the ones that we're using.
That we use a lot.
Yeah.
Okay, so that means the I for this thing. No. Go back. Yeah, wait. Perfect. So the I for the sphere is 2/5 of mr squared. So that means the torque is equal to 2/5 of the mass, which they said was 2, times the radius of the things. They gave us the diameter because they're trying to mess with us.
But it's good radius, so 0.25.
So it's going to be 0.5 divided by 2 squared, right?
Mm-hmm.
And then I have to multiply that by the angular. Thanks. Acceleration of 3 radians per second squared. So the torque is, who knows what it is?
0.25 squared.
Yeah, 2/5 times 2 times 0.5 divided by 2 squared times 3. It's 0.15. And the units on torque are Newton meters.